So this is the second area maze. And a lot of you had some really good guesses as how to do this question. But even those of you who got the right answer were still like, but I'm not like 100% certain, or I can't convince my friends that I'm right and they're wrong. Okay, that was a lot of the conversations I had. Okay, so firstly I'll tell you what the answer is, and then I'll tell you how I get it. The answer is 30. Okay, now just you guys know this, right? When I do this, like, this is not for me. I don't do this for me. I do it for you and for the benefit of all kinds of other people around the world who don't get to sit in a mathematics classroom like you guys do. And I don't really want to do it if I have to edit out 15 times when I just have to stop and look at people and then proceed. So it's really up to you. I gain nothing from explaining this to you because I have all the answers myself. I know what I feel like when I get frustrated, when I don't know how something works. I just need someone to give me a hand, okay? So I'm going to ask you to be courteous to your peers who actually are interested in this, or excuse yourself from the classroom. It's a simple choice, okay? All right, let's try again. Let me get rid of this answer, and I'll show you how I reasoned through getting to the area of that little rectangle over in the bottom right-hand corner, okay? Now this is tricky, this one, because unlike the first one I showed you over here, right, where you remember this 42? Remember this 42? We saw it was 7 by 6. So you can do your times tables for that, that's pretty good. But then you get to this guy, and the first number you encounter is 13. And 13's a bit of a jerk, right? Because 13 has what factors? 13 and 1, and you're like, you can deal with decimals, or you could deal with fractions, but you don't have to, and you shouldn't have to. There are other ways to do this. So here's what I did. Remember when we were like, I don't know what a number is, so I'm going to use algebra, because algebra helps me work with numbers even when I don't know what their values are, okay? So this rectangle over here in the top left, I'm going to say maybe it's A centimeters from top to bottom, and maybe we'll call it B centimeters from left to right, okay? A times B, right? Now, because you guys have done measurement before, you've done rectangles, so you know if you've got a height and a width, you can say, whatever these might happen to be, that A times B, that's got to be 13, okay? I don't know what they are, but I don't need to, okay? Now I want you to have a look over to the right of the diagram. Do you see you've got this other rectangle over here, this one here? Okay. I don't know how wide it is. Do you see how I know that there's this width over here, but this one is different, and I don't know what it is, okay? But look at the height. I actually do know how high it is, right? Because I already gave that a name. I called that A, right? So just like it's A over here, it must be A up and down like this, okay? Now, what's this guy over here? What is this? I'll just put a question mark there for a moment, okay? Well, just like I said, A times B is 13. This height and this width on this rectangle over on the right, A times whatever, it's going to be 26. Do you agree with that? Now have a look. If you compare this equation and this equation, you can see 13 and 26, that's not a coincidence. Those numbers aren't just like randomly 13 and 26. 26 is exactly double. It's exactly 2 times, right? So that means that, remember I didn't know what the width was? Well, actually I do know what the width is. The width is just double whatever the other width was. Okay, does that make sense? It's 2b. I don't know what b is, but I don't need to. Okay, so I'm going to say, right, this guy over here is 2b from left to right. Okay, now that's what I know. I'm going to move into what I don't know. Okay, this height over here at the bottom, I don't know what this is either. I really don't. So I'm just going to give it another name. I'm going to call it C, right? Now C times the same width over here, B times C, that'll give me the area, which is 15, right? So now have a look at the unknown. I'm finally there, right? I know what its height is, C, and I just now worked out how wide it was, which is 2b. Do you see that? 2b. Okay, so the area of a rectangle is its width times its height, right? And that b times c, I already know what that is. It's 15. So that's why it's 2 times 15, which is the 30 that a lot of you worked out. Okay, so you can see there were no pronoun rules or anything like that in the earlier part of the question. Boys, can you just wait outside for me? Just step outside, and I'll speak to you afterwards. Thank you. You can see there was no algebra in the question. Like, the question didn't say, hey, use algebra to solve me. But algebra is great. You should use it whenever you can to help you solve questions like this, okay? It's very, very handy. All right, let's have a look at number 3. This one doesn't require any algebra. Let me show you how I approached it. Some of you I gave a clue to. This was the clue I gave. I drew a line down like that and a line across. So I made this new rectangle over there on the left-hand side, okay? I'll highlight it for you. See this rectangle? I think you should be able to tell me how big it is. Can you tell me its area? It's 18 square centimeters. Where does the 18 come from? Yeah, Tarun.
3 times 6 because 1 is the length.
Yeah, very good. You can see this 6 comes across all the way from the right to the left, okay? So that makes this guy 18 square centimeters, okay? But that means if I like join another vertical line like this, have a look, you can see on the right of the diagram, I've got another rectangle that I know the area of. Let me highlight it for you. See this one? This one in red? What's the area of this rectangle? Yeah, Aiden.
24.
24. And you can see it's just the 4 by 6, right? 24 square centimeters. Now, that looks like an Italian flag. What's that white part in the middle? That's just the last leftover bit. Can you tell me how to work it out? No algebra required. Have a look. Yeah, Matthew.
43 minus 24.
Yeah, 43 minus 24 is exactly right, because 43 is that whole rectangle, and we just cut out that red bit, right? 43 minus 24, that's 19, right? 19. Okay, now what's really lovely about having all these numbers now is if I put in an outline like this rectangle here. Now I know how big that rectangle is, right? Because I've got the left-hand side, which is green, and I've got the right-hand side, which is white. So the purple rectangle is 18 plus 19, which is 37, right? But that's the same as the rectangle at the top. They're the same area. And look, they're the same width. Do you see that? So if they're the same area and they're the same width, what does that mean about the heights? The heights are also identical, right? They're actually what we call congruent figures because they're identical. They've just been moved up and down. So that's a 6 and that's a 6 there. So that's a nice easy one. Okay? All right, last one. Let's have a look. Did anyone get this one? Anyone get it? Okay, it's pretty tricky. I'll need to work hard to see if I can remember it, okay? So have a look. Okay, where did I start? Okay, yes, I remember. All right, have a look. If you have a look at this diagram and you have a look at these little lengths that have been put on either side of things, right? For instance, you've got this 4 over here, right? But that tells you what this distance is. Do you notice that? That tells you that the little distance must be 2 because 4 and 2, they give you 6, right? Does that make sense? By the same logic, if you have a look down here, right, you know how much that little length is too, right? It also happens to be 2. Because, same logic, in fact, 2 plus 3, that's what gives you the 5, okay? Now, hold on a second. Just look, just compare now. Let me highlight for you. Compare this yellow rectangle here with the gray rectangle that's on the right. Can you see that? Okay. Because each of them has chopped off the same amount here and here, right? Do you see they're actually the same height? They've just been slid up and down, right? One's gone 2 up and one's gone 2 down. Do you see that? Yeah. Okay. So therefore, whatever this height is going to be the same as this height over here. They've just been moved up and down from each other, okay? Can you see where you can go next? Have a look. What else can you use here? Can anyone tell me what is the width of that rectangle up there? A lot of you would have just written that down pretty quickly. How do you work out that width?
I think it's 13.
Yeah, I think it's 13 as well. How did we find out it was 13? Yeah, Trin.
78 divided by 6.
Yeah, very good. 6 times 13 must give you the area. So 78 divided by 6 gives you 13. That's 13. What about this one down here? What's the width of this guy? It's also going to be, that's not a coincidence, is it? It's also going to be 13 because 5 times 13 is 65. Okay, so now that tells you those two rectangles are the same width. That means I need a new color. That means this distance here and this distance here are also the same because they've just been moved one to the left and one to the right. Okay, so whatever this is and whatever this is, they're identical, those two green lengths. Okay, so we just worked out yellow and gray, right? Heights are the same, widths are the same. So I don't need to know what the height and width are, I just need to know they're identical, so it's 50 as well. Okay.